So this question is about kinetic energy of gas molecules in the thermal physics topic. So I'm just getting the data booklet out again to just show you where this is. So we're told the kinetic theory model PV is 1/3 nm, and that's the RMS speed squared. And then we've got the kinetic energy of a gas molecule is a half m RMS speed squared equals 3/2 kT. And using this equation, I should be able to fairly quickly get to an answer. So I'm using the a half mv squared effectively, so that's kinetic energy, but rather than v squared, we need to use RMS because it's in all different directions. And if we just use the v, they will average out to 0. So squared is 3/2 kT. We're given m, we're given t, k is a constant, and we're looking for this value. So it's the mean square speed. So the units will tell us if we're getting a bit confused with whether or not that means the speed or not. It's the square of the speed because the units are meters squared per second squared. Okay, so we need to solve this for this value. So we just need to substitute in our numbers and then use the calculator. So I might rearrange it first. So C RMS is equal to the halves cancel. So we end up with 3 kT over m, and that's all square rooted. So I put it all in the root side. So then I can substitute in the values. So K is Boltzmann's constant, and it's given to us in the data and formula book. And T is the temperature we're given the question, and M is the mass we're given the question. So we've got 3 lots of 1.38 times 10 to the negative 23. Multiplied by the temperature. It needs to be absolute temperature, so 750, but we're given it as absolute temperature. And then the mass needs to be in kilograms, and it is. It's 4.8 times 10 to the negative 26 kilograms. And all of that square rooted. And people make a mistake of forgetting to do the square root, so let's make sure we don't do that. So then putting that in the calculator, we get 3 times 1.38 times 10 to the negative 23 multiplied by 750 divided by 4.8 times 10 to the negative 26, and then square root that whole thing. And we end up with, it's a third 75 root 115, which is at 804 meters per second. But it's the square of the value. So I shouldn't have done the square root, because now I'm checking and checking again. So sorry about that. So we'll square that again, and we get that it's 646,875 meters squared per second squared is our answer.